Download this code and get free GPT-4o from codegive.com, link in the description below. Certainly. The valid parenthesis problem is a classic algorithm problem that can be efficiently solved using a stack data structure. Let's go through a detailed tutorial on how to solve this problem using Python. Problem statement. You need to determine if a string containing just the characters, and is valid. An input string is considered valid if 1. Open brackets must be closed by the same type of brackets. 2. Open brackets must be closed in the correct order. Example. Input, s equals, rightward arrow output, true. Input, s equals, rightward arrow output, true. Input, s equals, rightward arrow output, false. Input, s equals, rightward arrow output, false. Input, s equals rightward arrow output, true. Approach. 1. Use a stack. A stack data structure is ideal for this problem because it follows the last in first out, LIFO, principle, which is perfect for checking the order of parentheses. 2. Mapping brackets. Create a mapping of closing brackets to their corresponding opening brackets. 3. Iterate through the string. If you encounter an opening bracket, push it onto the stack. If you encounter a closing bracket, check if it matches the top of the stack. If it matches, pop the top of the stack. If it does not match or the stack is empty when it shouldn't be, return false. 4. Final check. After processing all characters, if the stack is empty, return true, indicating that all brackets were matched properly, otherwise, return false. Implementation. Let's implement this logic in Python. Explanation of the code. 1. Bracket mapping. A dictionary bracket underscore map is used to map closing brackets to their corresponding opening brackets. 2. Stack initialization. An empty list stack is initialized to keep track of opening brackets. 3. Character iteration. We loop through each character in the input string. If the character is a closing bracket, we check the top of the stack. If it matches the expected opening bracket, we pop it from the stack, otherwise, we return false. If the character is an opening bracket, we push it onto the stack. 4. Final check. At the end of the loop, we check if the stack is empty. If it is, the parentheses are valid. If not, they are not valid. Time complexity. The time complexity of this solution is O(n), where n is the length of the string, as we process each character exactly once. Space complexity. The space complexity is O(n), in the worst case, where all characters are opening brackets. Conclusion. This problem is a great exercise in understanding stacks and how they can be used to solve problems related to nested structures, such as parentheses. The provided solution efficiently checks for valid parentheses using a stack-based approach in Python.